Okay, so hello and welcome to the second Thames Valley AI Hub event, AI in Transport and Urban Planning. My name is Sarah Werts, and I'm a Business Relationship Manager at the University of Reading, and I'm also the Lead Coordinator for the TVAI Hub initiative. So before we begin, I'm just going to give you a bit of information about the Hub and explain how the event's going to run. So we created the Hub to connect our local AI community to accelerate innovation. The Thames Valley is home to a large and thriving AI community, and we want to make sure this region is internationally recognised for its expertise in AI. So we're trying to bring people together, enable collaboration, and ultimately develop a pipeline of talent for employers. So we've been going for 5 months now, and a priority during that time has been to build our network and also to set up an extensive programme of events. We decided to focus on events to begin with because they're such a good way of showcasing state-of-the-art developments, generating discussion, and sort of enabling that sort of valuable collision space. This is the first online event we've run, so please bear with us if there are any technical difficulties. Fortunately, I'm being supported by my colleagues Rowan and Claire, who've helped organise the event. Rowan, Claire, would you like to introduce yourselves and explain what your role is in the Hub?
Sure. Good afternoon, everybody. My name's Rowan. I am a business relationship coordinator. I'm based at the Knowledge Transfer Centre at the University of Reading alongside Sarah and Claire. And I have been co-managing all the comms and marketing for the event. So hopefully you all would have seen, or some of you would have seen, the post that we've been putting out on social media to try and attract you to the event. And we're also trying to capture it, and we'll share things after this one and promote the next one. So, thank you.
Good evening, everybody. I'm Claire Stratford, and I'm the Thames Valley AI Hub Network and Events Manager. I also co-manage the marketing content for the group alongside Rowan. We are keen to engage in dialogue with the community members and would welcome your input on activities and topics you are interested in. So please do connect up on LinkedIn and Twitter and get in touch. Hope you enjoy the evening.
Great, thank you both. As this is the first online event that we've run, we've tried to keep it quite simple, but we understand the importance of networking and such a key feature of the event programme. And so we're looking at ways so we can help facilitate that a bit better in our events going forward. So how is today going to run? So just to alert you that the webinar is being recorded. If anyone has any concerns about that, please use the Q&A function to let us know. Please do use the chat function for general discussion. We're really keen to hear from as many of you as possible. If you'd like to ask a question though, can you please use the Q&A function? The way that Zoom webinar works, that it's much easier for the panelists and the organisers to manage the questions if the Q&A function is used. When you ask a question, we'll be able to see who it's from, so if you'd rather stay anonymous, then there's a tick box that you can select. Everyone should be muted, but can you just check that you are on mute, just in case any background noise can disturb the speakers. When you log out, you'll be asked to complete a short questionnaire about the webinar, and it would be great if you could complete this for us. The feedback is totally anonymous, but the Hub is for the community, and it's really important that we understand what you think, so we can improve our events and our content. If you're experiencing any technical difficulties, please do contact us using the Q&A function or email us at tvaihub@reading.ac.uk. So we've got a fantastic agenda for you today. I'm absolutely delighted that John Harding, a lecturer in architecture at the University of Reading, and Scott Witchalls, Director of Transport and Infrastructure at Stantec, are able to join us today. So each speaker will talk for about 20-25 minutes and be followed by about a 5-minute Q&A session. If we have more questions than we've got time for, then John and Scott have kindly agreed to stay for a panel discussion at the end, but the meeting will finish at 7:30. So just in case anyone has to leave before the end, I just wanted to highlight our forthcoming events. On Wednesday, the 17th of June, 10 AM till 12, the Knowledge Transfer Network's AI manager will be coming to talk, and attendees will be able to find out about the latest funding opportunities from Innovate UK, and also how COVID-19 is going to affect the innovation funding landscape. Then on Wednesday, the 15th of July, 4 PM to 6 PM, we're hosting an event, AI in Law and Intellectual Property. Harrison Clark Rickaby Solicitors and an Associate Professor in Law from the University of Reading will be presenting, and we hope to get the abstract for that event circulated in the next couple of weeks. If you'd like to sign up for either of these events, please do so through Eventbrite, and you'll be able to find the link on our website and also on LinkedIn. And you can see the details of us on the page here. As I said, the hub is for the community, so please do get in touch with us. We'd love to hear from you. As well as highlighting latest developments in AI, we're also signposting to business support services, relevant funding opportunities, and really trying to make our network get the most out of all the opportunities that are available. So please do follow us on LinkedIn and on Twitter, and check our website regularly for content. If you're planning to tweet during the event, can you please use the hashtag TVAI Hub? Okay, so that's all from me. I'm now going to hand over to our first speaker, John Harding. So thank you, John.
Thank you, Sarah. So I need to share my screen now. Okay, so hopefully you can see my screen. Hello, everybody. Slightly odd talking to this virtual audience, but want to first of all say thank you for the invitation to speak today. I'm an architect. I'm a lecturer in architecture, but I also worked in industry for 15 years or so before becoming an academic at the University of Reading. And I want to give you a little bit of a background today, what we do in the architectural world, which is this kind of curious mix of arts and sciences. So I'm going to give you a little bit of background on that. So I want to start with a project that I worked on about 9 years ago now, I would say, with an architect called Bjarke Ingels Group, and they were making lots of different design options. And as architects, we tend to use lots of different media, foam models, sketching, and more recently code. And we tend to go between all these different types. And I always bring up this project as an example of where it's actually very difficult to have this kind of variety with a machine. So actually generating something or these different design options very quickly, things like sketches and foam model making can be much better. But there are some disadvantages to this because we can't get analysis out of foam models very easily. And so those two kind of methods, finding ways to go between them is really important. So this is the classic loop of going between models, analysis, and then feeding that analysis back into those models. And as you see in architecture, we tend to use all these different things like sketches, CAD, of course, and code, collages, kind of very loose artistic things. And then we try and bring them in and have some sort of analysis to influence how we develop a project and how we iterate through a project. And some of those are quantitative, so there might be things that we can simulate, such as thermal comfort or structural performance, those kind of elements. Or they might be very kind of tacit, qualitative qualities, such as you know, what do I, if I moved a particular building in the design development, how would that affect the social aspects of the space, and things that are very hard to actually put a performance metric against. That's what makes architecture kind of interesting. That's why I'm interested in the field. But it's important to note that they always change throughout a project. These things always change in reality. So there's no kind of goal that you state at the start and remains the same. And contextually between projects, so you work on lots of different types of projects in architecture. They're always different. They always have different sites, and we can learn from some projects, like in terms of the kind of sectors they're in, like residential or office, and we have certain kind of rules of thumb, but we're always trying to change those, and we're always trying to adapt to a particular different site. So I think it's worth bearing that in mind whenever we talk about how we can use computers in the process of design. So modeling design options. So of course we know that when we use kind of computer algorithms, we know the advantages of using code and churning out lots of different design options very quickly. But it's how to get that variety of those kind of foam models and sketches and going between the solutions that's the difficult bit. So we tend to, in architecture, use a mix of lots of different scripting languages and coding languages, of course, but also in a kind of mid-range entry level, lots of data flow programming, visual programming, and like acyclic graphs, directed acyclic graphs. And I just put this one up here because this is a classic kind of model that we use to sometimes teach the students about coding and design. So this is a souffle. Souffle has certain ingredients, it has certain amounts, parameters of those ingredients, and we kind of mix them together, we perform functions, and we end up with this kind of souffle. And we know that souffles are very hard to make, so I think it's always a nice example to use. But those little functions, these kind of methods here, they in architecture can be anything. They might be formal, they might be a material choice, there might be a combination of where to put certain things in a building, and they operate at all different scales. And architecture is one of those things it's very hard to actually do something one-to-one. So it's not like product design or something where you can do a one-to-one mock-up. You're always having abstractions, and we use a lot of scale models and a lot of scale drawings. And that has to be fed into the model, even if it's this kind of computer model. So a very simple, let's say a kind of CAD geometry, the classic architect would model something in CAD. But actually, when we're thinking about programming, we're thinking more about the logic of how something is made. So of course, a data flow program, we might go from a couple of points to a line. We then divide that line into points. Then we make some surfaces and we extrude between those surfaces. And we end up with a piece of geometry. And that geometry, because we've set it out explicitly in this data flow program, of course, we can change a variable, we can go back to a variable and change that parameter and explore a different design option. So that's a very simple one. Moving on to kind of something a little bit more complex. So we use the same process, a kind of input parameters, an output design option, might be something like a massing scheme at a very early stage of a project, where we put in certain kind of bespoke rules, like a courtyard, or how we divide a plot, how we divide a space, its relationship to the site, of course, the context. And then it generates different design options within that kind of sphere. So for instance, we might have a little algorithm that generates all these different massing models, and we can get some feedback on those massing models and the different alternatives by running, like I said before, through different types of analysis. So typically this is like solar radiance kind of analysis that was done when I was back in an engineering firm called Ramboll, actually. Where we took lots of different design options, we then run them through very quickly, and then we can have some sort of performance metric between, and we can look and compare different designs very, very quickly. And of course, you know, we look at those spider plots, those radar plots on the right-hand side for different metrics. They might be structural, environmental, all kinds of different things that we can measure. So the important thing here is that we're enabling a way to do something that we can't do very easily using sketching and physical models. And of course, then if we feed that back into the process, that's essentially what optimization is, using some sort of meta-heuristic algorithm or something like this, but we'll come on to that in a bit. One of the things I said in this project before about this sketch models is we actually tried, we were asked by the architect when I was working for the engineers, could we actually write some code or do something that can create this kind of variety so that we can actually look at things like, very simple things like what's the floor area of this scheme? Because actually when you make a little foam model, it's actually quite hard to do that unless you stick it in a bath or something like an Archimedes principle. You can laser scan it, of course, but that takes time. And so to actually have that flexibility, you have to look in a combinatorial sense of finding ways not just to adjust parameters, but looking how things are combined and going into that kind of more kind of abstract way of thinking. So here are just those foam options with some different parameters, but also different geometric kind of grammars that go together in different ways. And obviously this is very schematic. I'm giving you a bit of introduction here. But we can look at different ways and more kind of complex operations within that kind of grammar. So here is an example. I can't mention the project, unfortunately, today, but where we worked with architect and we looked at sketch rules. So we got together an early design team meeting, put a lot of kind of these grammar rules into the system. And then from that kind of system, we could then generate different design options. And yes, there are certain rules that we know that are global. So our experience as architects kind of know, like, a building has to be a certain width, let's say 40 meters for cross ventilation and things like this. So we're kind of putting that kind of knowledge into our models. But then we have to also be very careful that when we go between projects, we don't just assume that that knowledge applies. And I think there's obviously in architecture there books like A Pattern Language by Christopher Alexander. It was very famous for trying to get some sort of logic systems that we can kind of use again and again. But I think it's kind of, we're a little bit hesitant in this day and age to do that because we can't make those assumptions very easily. Because of course context changes and environment changes. You know, it's changed since Alexander's days, you know, 40 years ago. So I think it's really important just to mention that now. So we try and put those rules in bespoke project to project. And then this is almost like a kind of combinatorial of those functions and changing the parameters, but also the functions themselves and how they go together. And that generates different design options that are getting a little bit more towards the variety maybe in the foam models. But of course, they're highly dependent on the grammars we choose. And of course, they can end up creating very hard to understand connections between input and output. So of course, we have input of the parameters on the left-hand side. Lots of functions that are very hard to understand by humans, and an output, which is the geometry itself. But this is almost a bit of the limitation of these kind of data flow programs, if you like. And anyone that knows anything about genetic programming, so John Kozer, that kind of history, looking at combinatorial trees, to try and get more kind of variety in the outputs of functions. There's obviously a kind of relationship to what we're trying to do here, but there is a limit. Things like bloat and things like this that come into some of these techniques like genetic programming. But this is just an example showing, this is a different architect, 3D Read Architects, where we looked at doing this kind of logic, and then we generated very quickly this kind of different design options. And these design options were kind of interesting because we actually benchmarked these against some of the techniques that they were using in the practice, like just sketching and model making. We found that it was very nice to highlight ways that, or it would reveal kind of patterns or different configurations of spaces that weren't necessarily obvious. And that's the beauty of computers, right? They have this kind of naivety that we want to try and exploit in some ways. So that's kind of a bit of a kind of symbolic kind of genetic programming to generate form that we use. We also have different techniques such as CPPN. Some of you might have heard about this, where they're non-symbolic. So they might be combinations of functions that have inputs and outputs, and these can get very complex. But we have a kind of voxel-based output that has kind of a marching cubes to create this kind of surface or some sort of form. It's essentially a neural net, so pattern-producing networks, and they can be evolved as well. We'll get onto that in a minute. But another kind of method, like trying to generate floor plans, but learning from past examples. So this is recent work using GANs, adversarial networks, where we're learning from past examples, and then we're taking a boundary or kind of a site boundary or something, and then from the past examples, we're generating different design options. But these are highly dependent on learning from past examples. So we feed in, you can feed in all kinds of different styles. So the styles are not explicit, but the neural network learns those, and then it kind of feeds them in and outputs them for a different boundary case. So obviously the training set is really important here. And this has been used for three-dimensional examples more recently, David Newton. But this suffers actually from lack of training data. So actually historical data on forms that can be trained on these kind of three-dimensional networks. And you go straight into the final design. So this is another thing that we need to be careful of, because expert systems, we know from the 1970s that there's a risk of computers kind of dominating the process, if you like. And architects, as a, you know, they like control. So there's this kind of problem that if the machine tells you how to do it, you know, you have to be careful and you have to almost trust the machine, and we'll get onto that in a minute. But I think it's important to note that those lessons from history when we're trying to use some of these techniques. So these kind of layout systems were not really adopted by architects 20 years ago, light shape grammars, and they remain in academia. And I think we just have to be careful nowadays not to make the same mistake with some of these techniques we're using. So guiding the search process, when we have lots of different designs, and I mentioned before about it's very easy if we have a very, it's not easy, but it's if you have a very clear defined metric like a structural analysis metric, we can optimize a truss, for instance, we can minimize the deflection with this kind of modeling analysis feedback loop, and those that have done reinforcement learning or something, it's kind of a very similar loop. And that's a structural example, environmental examples. So in environmental design, there's lots of benchmark cases for optimizing certain shapes and openings, and you can see some of the parameters on the left-hand side here for these kind of building examples and optimizing them in terms of energy use and these kind of factors. So I urge you to have a look at some of these papers. There's a recent one here, 2019. But again, this Stanford Anderson puts it very nicely, that it's very hard to state all the problems that a building has to solve and measure those. So we're always constantly changing that objective function or cost function. So actually, there's a history of interactive evolutionary systems where I love this sketch by William Latham on the left-hand side, which is an iterative approach, which is just guided by what he feels right. So it's almost like a systematic process of design, but it's guided by a sketch that iterates and changes over time. And of course, Richard Dawkins' Biomorphs back in '86, a kind of computer version, first version of that. So a kind of not an objective function, but guided what feels right. So we've generated a kind of series of tools that use similar kind of interactive evolution with the data flow programming I showed you before. In this case, this is evolving sculptures that kind of Henry Moore sculptures, but they could be buildings, could be anything. But it's, I think with this kind of problem, it's all about context, like which bit of software we're using and integrating with. So then we have this kind of history of interaction and design evolution that's guided by, again, kind of what feels right and not necessarily what's the cheapest or what works the best structurally. But it's important to keep those things in the back of your mind as you're developing these projects, of course. And this is just an example of like evolving interactively different building designs. Handling large design spaces. So this is another factor with some of these problems. So if you're doing interactive evolution, generally people like a small design set. So like maximum maybe like 12 designs to compare as you evolve. But of course, large population sets are very advantageous for traditional kind of optimization. So how do you go between those two if you have a large population? We use techniques, you know, classic kind of k-means clustering. So we cluster similar designs, and then we visualize the similar designs in this one here. So actually this design almost represents a cluster of like 15 alternative designs, but it's similar to that one. And of course, k-means, this is a picture of my daughter actually doing a bit of k-means clustering with Lego, trying to sort out into different colors. And it's a way of actually visualizing different design options to others. And it can be tremendously powerful if you've got lots of different design options you want to show. And just a few examples using that, again, like Andrew, these guys at MIT doing some work just using clustering algorithms of building plots in urban design spaces and finding similarities between them using k-means. K-means is fine, but clustering, as we know, has its problems because you're not getting a kind of associative view of the whole design space. So if we cluster into individual bits, if you like, you know, which bit is similar to which other bit. And this is where we start to look into things like self-organizing maps, which have this kind of way of visualizing high dimensional spaces in a lower dimensional form. An example of this, if you've got 2 dimensions, you might have something like 2 parameters, like a twist or density of a pattern on this kind of Möbius band. And we can visualize that very easily on a map, like a 2-dimensional map like this. If you have a building design, maybe you might have 10 parameters that generate different design options. And then how do you actually visualize those design options in a simple way using some dimensionality reduction? So some of the audience might know different methods like autoencoders and things like this, and dimensionality reduction. Obviously classic kind of T-SNE, these kind of different options for visualizing high dimensional spaces and lower dimensions. I like this artist, Dan Tobin Smith, who does these beautiful like color RGB values to 2D maps. And inspired by those, we've used these on trying to visualize high dimensional spaces to low dimensional maps. So here, this is something called a self-organizing map by Kohonen back in 1982, I think was the first kind of self-organizing map. So they've been around a while. They're not so used in the community, machine learning community so much, but as architects, because they're so visual, they're very beneficial. So here, if we have a 10-dimensional, so these 10 dimensions of that tower that was being constructed, that little GIF that was looping before, we can take, let's say, 16 of those designs, and we can map them to 2 dimensions onto the plane. And therefore, we can compare them between those different design options very easily and in a kind of visual sense. And I think it's tremendously powerful to be able to do that just from a low number of input designs, and then visualize them associatively using not clustering, but using a kind of a mapping 2D. I've got my timer on. I know I've got 5 minutes left. So we've got these as well, this example of using self-organizing maps for analyzing street layouts, and the guys at ETH. You can look at Musavi, who's done some nice work looking at using those kind of associate mappings to look at comparison between different urban design spaces. Mapping to 2 dimensions is also very advantageous because you have the 3rd dimension or something else to show, let's say, a performance of that particular building design. So if we can map the parameter space that generates the building down to a low dimension that can be visualized, we can use another dimension to visualize the performance. And again, when you're trying to explain to clients, this is very, very useful. So this is an example here. I'm not sure I can mention the project, but kind of very formal geometric project with early design ideas, sketching different forms, and then again, having this parametric model and having certain performance metrics, very early stage, but it might be something to do with solar radiation, heat loss, deflection. And then using the SOM as before, we can map the SOM designs to a kind of, so similar designs are next to each other, right? So this is what the SOM is so good at. It shows in parameter space that this design is similar to this design, and this design is not similar to this design right over here. But then we can show performance metrics, in this case, using contours or using color. This is solar radiation on these designs. We can look at deflection. And of course, we can use a multi-objective optimization or something like this using Pareto fronts. But I think these techniques give a kind of more visual way of looking at the kind of a snapshot of the design space. And I think they're tremendously powerful. So finally, I just want to end with this last little bit, which is learning from the past, okay, and explaining to others. So a bit coming back to the title of my talk, like how to not to trust computers, if you like. I also do a lot of work on supervised learning. So, well, I'll show you this example first from UCL, which is actually learning at how a craftsman would use a chisel and then replicating that in a robot. And learning, just supervised learning, so training this neural net so that some of those factors can be replicated by the robot and give that kind of human quality. And I'm also doing a project at the moment, just started a project with Copenhagen, the Royal Academy of Arts and DTU, which is looking at biopolymer and predicting, like trying to predict how biopolymers may print. Maybe I can do a talk on that at some other point. But the point is that you're kind of predicting something, but the input and output, the black box in the middle, it doesn't matter, right? So we know it works. We can train a ConvNet and we can do it very well, but we don't have to explain what's going on in the neural net. But when you take the example like a site and then you have this building proposal, it's never that simple. You know, you can't just trust a machine to do it. Sometimes you have to kind of explain and gain trust from others. It's not quite the same as examples. Let's say, like, if we train a neural net to learn like artworks over years, which has been done quite a few times, obviously using ConvNets in the last 5 years, it generates things that are outputs that are based on the learned examples, and the bit in between, we don't really, you know, there be dragons, right? So I think, yes, we can look at visualizing little kind of feature maps to find out how, like, something like the neural net has learned little layers. And that's done in architecture as well. But that doesn't tell the whole story, really, because in architecture, we make certain gestures, geometric gestures, like this example on the right-hand side, where we have to explain why we do something, right? So we might pull a shape, or we might move a building, and we explain that to a client. And that can't be hidden away. It's not something that you can kind of, oh, just trust me, you know. Now, yes, you're hired on your experience a bit, but I think it's really important to note that we always have a duty to explain a bit, right? And that varies on different projects, and we can't just completely trust someone. That's why you have public consultations. That's why you get the public involved. And recently, I love this work of Fujimura in Japan, recently, who does computational models, but then brings them back into the public realm to try and get feedback from public consultation on lots of different design options. And again, we could do a whole talk on that, but I think I would urge you to maybe look at that work, because I think it's very interesting, and it does raise these questions of how much do we make explicit, how much do we need to explain to a client, how much do I need to explain to another consultant, and that always changes, like I said. It makes things really interesting. This is my last slide, by the way. But I think just to come back to this, you know, how do we arrive at these options? Can we just trust the machine to do it? Can we just trust me running my kind of combinatorial GP thing? I don't think so. I think you do have to explain different stages throughout the project. And I think that's where I'd like to end, because it probably raises more questions than answers. And that's a good way to end, I think. So thank you very much.
Brilliant. Thanks a lot, John. That was really interesting talk. So the first question is, what do you see is the greatest challenge of architecture and AI, which is potentially hindering uptake? Is it the machine trust issue, or is it something else?
It's definitely well, obviously, I think when you're thinking about something like architecture, no, not every architect's going to have amazing skills. So in neural nets. So firstly, there's a kind of how much a general architect would know, and how much a consultants would know. I do think that the uptake, like I said before, like training data and things, we're a bit slow, I think, in learning from past projects. So post-occupancy is a key thing, and I think we could feed some of those bits into our learning and teaching machines. But I do believe it's a control thing. I think it's a trust thing and it's a control thing. I know with my colleagues, they just see me as this kind of strange person sometimes, right? Who does these computational things. And I think we need to try and, in a way, get out there and try and explain what we can. We can't explain everything, and nor should we, but we need to trust machines a little bit. And some things might be black box, but we shouldn't let everything be black box.
I've got a question here from Linda Sheard. She's interested in the software that you use for some of your visualizations, and also in where you do your computation. Is it of large enough volume to require distributed computing?
So a lot of because a lot of our work is geometric, we use CAD engines like Rhino, you might have heard of, which does distributed computing, does some parallel computing. We also do a lot of Python, of course, but we tend to ship out things, you know, we might ship out large data sets, do some work in Python, and then bring that back into Grasshopper. So that's the kind of, sometimes it's a bit hit and miss, and actually I'm never sure if we're really doing it as well as we could. so we obviously have lots of repositories and things, and but I think the difficulty is always when you have models and sketches and things like that. It's so hard to work between the different media. But I think yeah, that kind of grasshopper rhino environment is definitely where we centralize things a lot of the time.
Thank you. And just one final question before we move on to Scott. Obviously you work at the university, but what type of projects do you enjoy most working with industry? Is there a particular type of work that you enjoy most?
I tend to enjoy either work really early stage, so where there's lots of different opportunities where we can jump in. Having said that, I also do enjoy when you are given a very strict problem to solve. So if you're given, a bridge to optimize structurally, then you really get stuck into that. Or like I said, with this robotic biopolymer, where we're learning the best ways to do robotic prints. I think that's also, a good keynote. So any of those extremes probably is like the answer, right?
Brilliant. Thanks a lot, John. That was really interesting. So we now hand over to Scott.
Thank you.
Evening, everybody. Hopefully, sorry, a bit of pause there, getting things on. Hopefully, you can all see this. I'm sure someone will message me if not. So I'm Scott Witchalls, Director of Infrastructure, now Urban Places and Smart Cities at Stantec. So I just wanted to run through our thinking on urban planning and transport. So much less WYSI graphics and AI interface in this, because it's more about what we do. So transport's all about lifestyle and choice, which means it's about psychology, sociology, politics, philosophy, engineering, all those things lumped in together. So it's much harder to try to use computers to tell us what to do, because we're all selfish individuals, and rightly so. We're proud to do what we need to do. So just a quick bit of background on why it's challenging for us, because we've always striven to get better and faster and more capacity in our transport system. So we're driven by this desire for more capacity, lower journey times, bigger payloads, lower costs, all those sorts of things. And of course, what that means is we put ourselves into a challenging position, because it leads to successful economies, of course, which is a good thing, successful communities, bigger communities, but then that brings with it the need for more housing, schools, leisure, things to do. And as you develop new hubs, those hubs grow, and it leads to more travel demand, and then longer distance travel, because you create new places and enable those connections to those new places. The big problem we have then is, of course, that historic infrastructure that was put in place to make that society work was designed to a certain cap, and it can't achieve the capacity needed. So that outstrips the infrastructure capacity. And what we then tend to do, and why we've, as engineers and transport planners, got ourselves into this terrible mess we're in, is because we adopted this self-defeating approach. We had something called the motor car, which is fantastic, created all sorts of freedoms, enabled us to get all over the place whenever we wanted to, wherever we wanted to, and that encouraged us to build more and more roads, and that then led to more and more places more remotely placed that are only connected by road and only accessible by car. So that's the challenge we have. So to try to reverse that now is a huge challenge, and if you go back several hundred years, it worked quite well, because they traveled by river and rail. They didn't have cars, but now we do. So we've got to work a way around that. And our sustainability challenge is really linked to these themes. The first, which is the link between transport planning and design, and urban design and town planning, is not so much don't travel, but think about how you design your places and where you put things and the size of the things to try to reduce the need to travel. So communities that have all the facilities and services they might need in a close proximity are obviously going to be more sustainable. And then that means that we can ensure that most people can travel by foot and by cycle. And if they do have to travel by motorised means, we need to plan and understand which one of those might be the most sustainable and how we can achieve that. So that's where our biggest challenge comes in. the fact we're dealing with people and lifestyle and behaviour and choice, and then how can we make sure those choices help give us the outcome we want to achieve. So the back end of 2018, 2019, we did a bit of research with the Independent Transport Commission to try to understand if anything was happening in people's lifestyles, particularly the younger generation, and looked at all those factors you can see in that right-hand box. Were any of those things making a difference? And what we were seeing is there were some trends emerging in terms of particularly different age categories about their attitude to travel and transport, and what they wanted to spend their money on. More importantly, the way their choices in lifestyle affected the way they travel. And they were conscious about climate impact as well as an emerging important factor before climate emergencies were declared. But particularly in the younger generation, you can see that in this trend slide, particularly men aged between about 16 and 40, there was a downward trend in...
sorry, Scott, I can't see your video. I don't think you're sharing the slides. I can just see you.
I've got them on my screen, hang on. That's not... let's see if that's... Is that... Sorry, is it there yet?
Is there a green share screen button at the bottom of your screen? Is it not working?
I've clicked share screen.
Oh dear.
Hold on a sec, let me just see if that does something.
Here we go. Is
that better?
There you go, brilliant, thank you. Sorry.
Right, now let me get back. That one. I'll be back. Right, hopefully we're back. I'll just try not to. Let me quickly whiz back to, I won't bother with these are the things I talked about. But the last slide I was on, these are the sort of behavioural things that we were looking at to try to understand what people were doing. And then this was the trend slide I was talking to about. Certainly males and younger generations were travelling less, so shorter travel distances, and certainly much lower travel by car, less tendency to want to own and buy cars. And these are things we wanted to capitalise on, because if we're going to try and unlock the problem of congestion, then we need to ensure there's a change in the way people travel. And in central Reading, some of you will know it very well, there's been some success over the years. So we have a trend of economic growth. So Reading, in the last 10 years or so, has grown successfully economically. But you can see from this slide, hopefully, that the number of cars and taxis into central Reading has dropped, and public transport and pedestrian cycle numbers have gone up. So we know that we can achieve economic success without car growth. So that's one of the key challenges we're trying to resolve. And the other key factor, this research we did was before the climate emergencies were declared, and people were starting to declare them, and we saw a big change. So back in February last year, these were all declared climate emergencies in the UK. But then you only got to jump forwards 8 months, and pretty much everybody had declared a climate emergency. Most of them didn't actually know what it meant or what they were going to do about it, but they knew they had to declare one. What followed then is them all fighting each other for the best target in terms of a zero carbon economy. So you'll see various authorities setting their own net zero carbon targets, and they range from about 2030 to 2040, depending on where you go. So those are big catalysts for change that we've been able to look at and capitalise on recently. And of course, for us, the reason people are interested in travel is because transport is the biggest contributor to CO2 in the UK, and it hasn't gone down for the last 25 years, and that's because of those things I described earlier. We're travelling further by car, We're becoming more car dependent, traffic is growing. And even though vehicles are getting cleaner and cleaner, they're also getting bigger and bigger. So, you know, there's no net gain, there's no benefit. So we know this isn't working. So what you'll have heard is the technology solution to all of this is electric vehicles. And it is a very good answer. It's quite a straightforward answer that people can understand: electrify the fleet. So we have a big challenge though. If we want to be net zero carbon by about 2030, we won't be all electric until beyond 2045 because of the length of time vehicles are out there on the road network. And also an all electric vehicle is not a zero emission vehicle, even though the manufacturers call it that. First of all, you've got to get the energy from somewhere. And secondly, there are harmful emissions from things like braking and other tyre emissions. So they're not zero emission, they're still harmful to health. And of course, how you produce them has a carbon footprint and is quite damaging to the environment as well. So those are things around the vehicles themselves. But the other piece to electric vehicles is the amount of electric vehicle charging points you need and the rollout of those across various streets and cities and town centres. And there's a major concern now about the impact of all these chargers popping up on the public realm and the place. And we're moving very much more towards place-based design, community-led place-based design, and what people want in their places. And actually, most people don't want lots of quite ugly charging points with cables all over the place in their high-quality communities. Of course, the other factor is the technology isn't going to solve the congestion. The technology might have zero-emission vehicles, as they call them, but you still are going to have the problem of congestion if we don't change something else. So we need to, in our design and our consideration of design, we still need to think about the behavioural aspects of it. So it's much harder to use computers and tools to design when you're dealing with human behaviour. But actually what's been brought home most recently is this dreadful experiment we're all in the middle of. And this is just the COVID-19 data from Google for Reading, showing what's changed. This is up to the 7th of May. So massive drop in travel. So ranging from 10 to 70%, depending on the reason for the trip. But you can see that workplace trips drop by 70%. And transit stations, which is basically Reading Station as a mainline hub, a massive drop as well. So those things are things that are happening as part of this experiment. But what we're now trying to do is say, is there anything we can learn from this? What we're learning is there's more community spirit emerging. We're learning that people are quite enjoying the fact that the roads are quiet and safe and you can cycle and walk. So we want to build on that. And this goes back to a slide from the 60s that it still holds true, that if you can get the same amount of people in that much space, it's a much more efficient network, which is what we're striving towards through our better design of places, is much more efficient networks. And that is where the computational power can really help us. So that naturally takes us towards what we mean by how the computers can help control our lifestyle and choice. And they obviously can't, but they can help inform us. And that comes into this whole concept of smart cities, a holistic city with a comprehensive vision and plan. And then the key part of that to achieve what I've been talking about is the land use plan, and then the smart mobility layers that sit behind it. So this is a piece of work we're doing for Google on Sidewalks Labs in Toronto, but they're building their digital twin as they go. And this is the sort of thing we're talking about trying to achieve. So we have a live digital twin of a place that is informing us all the time about what's happening in that network, how people are moving around, why they're moving around, how we can help them move around more efficiently or with a lower carbon footprint, or any other parameter or driver that they're interested in terms of their own lifestyle and choice. So those are the things we want to be able to help them with. And the things down the right-hand side there are some of the aspects to that. But really, this is more about informing those, not just the buildings. You've seen about building design, how data can help inform how the buildings operate and are used, but it's more about the communities, about how we can influence what the communities do through those data layers. And I'm sure that's what it will look like when it's all finished. But the concept is that this is a place managed and controlled by the data that the people that are in it are giving back to the system. So that system's helping them get the most out of the place and getting the thing they want out of the place. So you predetermine that by asking those communities what is most important to them, what things they want, and then you try to use and mine that data as you go to give them the choices that they've selected. And of course, this is all assisted by the massive growth in data and devices. The big challenge we have is, you know, the data exhaust, as it's known. How do we get rid of all the rubbish? We need to feed in the data that's most relevant to those people, and we do that by providing them with the information they've selected through the use of apps and through other devices that can help them be better informed. So as I said, what we're trying to do is create effectively more with less. So as you just heard about building design, the same thing we need to think about the space between the buildings. So everything between the buildings, the parks, the streets, the roads, the footways, the cycleways, how can we use those spaces more efficiently and better? And can we achieve the outcomes we want to achieve? So how is the power of AI and computers helping us here? Well, historically we have, in terms of transport planning, we've taken forever gathering data, and it's cost an awful lot of money. So we've struggled to, and then we're trying to predict human behavior just by observing what happened, just by counting things. But unless you drill down into what they're doing and why they're doing, it's hard to predict. But what AI is giving us is a way of gathering data more effectively, much more affordably. So this is an example of Vivacity Labs sensors that are in London now, and TfL are starting to use that data to identify where the cyclists are, where they're going. So these live AI feeds can tell TfL how many cyclists are going past any one point at any one time. Similarly, they can identify the difference between a bus and a motorbike, and a taxi and a cyclist and a pedestrian. So these AI sensors are recognizing what's happening in front of them and feeding that data live in. So we can use that data to understand where people are, how they're moving around, and how many of them are there. And that can help us design the new streets and spaces that we want to create. And then this links back to the whole theme of smart cities being dependent on smart mobility. And this is where it's a combination of design and data. We have to create accessible spaces and accessible vehicles. So we're thinking about the whole community. Where we can get the most capacity and the most efficiency is by automating all of those systems. So if we can create the mobility systems that use that data and computational power to make best use of that space, then we'll get much more capacity out of our space between the buildings. You know, you might call it the road networks, but it's not just the road networks, it's all the space between the buildings. The autonomous vehicles will use the road networks, but the power is in the data we can provide to them. And where they really come into play is where the data they're sharing is connected across various different things. So we need that data from each vehicle to be shared to all of the hubs of transport networks, and we need to be sharing the data between those vehicles. And that is happening at the moment. Connected autonomous vehicle development has a vehicle-to-vehicle comms protocol. So those vehicles will all be talking to each other, but we need to take it beyond that, and we need that data that's being gathered by all of those vehicles to be fed into a central network that actually looks at the holistic travel network rather than just how those autonomous cars are moving around. Of course, we've talked about electric vehicles being part of the solution to saving the planet in terms of carbon footprint, but it's the sharing that is the most important piece of this. We can't just have electric vehicles with single people in. We need shared vehicles, and we need a sharing economy. So the other piece of the cake here in the sharing economy is how we manage that, how we make people pay for things, how they choose, how they're going to travel. And again, that's where we need that computational layer to sit behind it to understand what choices you have and how you make those choices and how you pay for them. So you will have seen massive development in the world of autonomous vehicles from car manufacturers, and 90% of those vehicles look like cars because people are still sat behind wheels. So what we need is a big boost in the development of shared autonomous vehicles, and there are a number of new concepts emerging now, because I think those manufacturers have started to realise that actually people are more interested in the place, the lifestyle, the choice, than they are in personal ownership of a lump of metal. So we're moving towards the shared autonomous vehicle model as being where we'll be in several years' time. And also, as I mentioned, that the only way we're going to make this work effectively is if all that data is going into the central hub and is being analysed and shared back out to us, the people that want to move around in those networks, so we can make the most informed choices. And that's where we need those AI layers to be feeding in. If we make a selection, we need to know we're making the right choice about how we travel. So the mobility as a service model is something that fits very well with this, and that is where it's rather like you buying a data package for your mobile phone. In due course, you know, if we project forward several years, we can see that actually people won't be going out buying cars and paying for individual train journeys and bus journeys. We'll be paying like we do with our phones. We'll be paying a monthly package for movement of any type, and there'll be a certain way you can move around, and you can select that depending on exactly what you want to do at that time. So the data being fed in will give you those options, and you can choose for your package, and it will tell you immediately which one has the lowest carbon footprint, which one's the quickest, which one's the cheapest, which one's the most convenient. So you'll be able to select that, and those options will be readily available, and that all needs to be controlled by a hugely powerful network behind it. So just in a bit of future thinking, when I was doing some work for the university and Reading UK on Reading 2050, we were thinking about, well, when will this actually happen in Reading? But more generally, when's it going to arrive, this utopia? So actually, we've got lots of technology being developed and fantastic trials, but we've got a long time to wait because of we're creatures of habit, and we've got an established way of doing things at the moment. So the biggest challenge is the behaviour change. So in about 5 years' time, based on current projections of sales, we'll be about 10% on an electric vehicle network. And we'll have a few, not many, but a few limited autonomous shuttle services running around in our towns and cities. Maybe in Reading, in some of the bus lanes, you'll see vehicles like the Ollie there running up and down the bus lanes. So not all that exciting in the next 5 years, but beyond that, it gets much more exciting. So by 2030, a further increase in electric vehicles. But this is where I think the mobility on demand services are going to start kicking in, and those sharing economy services. So data, instead of having fixed bus routes and fixed networks, you'll be able to tap in where you want to go, and the vehicle will be able to optimize its route to come and pick you up. So those are the on-demand services that have so far proved pretty difficult to run. They're high cost, and they've only really worked in rural communities, but they need heavy subsidies. But with these new models of lower cost, high power computing behind the systems, free to run payment systems, then those things become much more affordable. And also, let's not forget that, you know, that what this lockdown has taught us is that we can actually do a lot more remotely. And with the advance in technology, certainly in terms of AI and augmented reality and virtual reality and holographic imaging, I can see us at least 50% of our business trips being replaced by virtual environments, because we know we can make them work, and we know this is very good for the environment to not have to travel so far. There's also an awful lot of trials around drone deliveries, and that's last mile logistics. So moving around micro drones or larger vehicles around urban centres, also flying vehicles, unmanned aerial vehicles. They will have their place, but I think, you know, we need to be careful about the what I would call the environmental harm of those, because they are not only they're noisy, they're visually intrusive. I don't think we want our cities full of things flying around over our heads. And of course, they've all got cameras on, so we're quite nervous about what that means in terms of data security and them looking in everyone's windows. And then if we project forwards towards the end, 2040, almost all electric, this is where I can see, you know, we will have moved dramatically to car-free towns and cities and full micro-mobility network. So rather like the cycle lane network being rolled out in London, I think every town and city will have replaced road space because of these efficiencies with completely segregated, safe micro-mobility networks, which are walking, cycling, scooting, that sort of thing, and these much larger, fully autonomous public transport vehicles that link to our mobility as a service network. So then obviously by 2050, the end of Reading 2050, this is where I think we can be realistic. We can say, look, by that point, we should have a fully zero emission, fully shared autonomous vehicle network. And that will be entirely controlled by the computational power behind it and the data that's being fed to it second by second to make the use of that network much more efficient. So just to finish off on that, I think in terms of where we're at with AI in transport, we're really just getting started. There's masses of trials out there. There's lots of AI experiments going on, looking at how we can use the power of AI to help inform us better. But the problem we've got at the moment is it's sitting in silos. So the people developing autonomous vehicles are developing AI for that purpose, and they're not sharing it across the broader transport picture about how we manage our lives and what we want to do, what place we want to live in. So we need to start sharing that across the silos, and particularly linking it to things around health, air quality, safety, those factors that need to come in. And this is why I say that the real benefits will come once we start sharing that data across the systems and across the sectors. But, you know, we can put all the technology we like out there, but it's really the social disruptors that are going to have the big influence. So we're giving them the tools to give them good choices and enable them to make those changes. But those are going to be driven by things around community, climate and health, rather than just the technology. So technology is absolutely vital to this, and the enabler that will allow us to do these things. But just the final point, all of those mobility packages, all of that transport network management system, it's all going to be, it's not going to be controlled, and you're not going to be dictated to by AI, but the decisions you make will be led by that AI behind the scenes. Thank you.
Brilliant, thank you, Scott. It was really interesting. I've got a question here from Adrian Orenson-Storier. He was wondering if you have any thoughts on the privacy implications of the use of AI surveillance. Is there a balance to be achieved here?
Yeah, absolutely. That's a really good point, because the data that you don't know you're giving away at the moment is something that's been a big issue for us. So the example of the cameras in London, those record very short video sequences and then delete it. So there's no link back to the individuals. Obviously, the mobile phone operators will tell you if they're using your device to track where you are and what you're doing, that doesn't get shared with anybody in terms of who you are. The fact that somebody moved between two places does get shared. So this is a key challenge, because if we can't use that data in the way we need to use it, because there are restrictions on sharing, and there's a personal preference not to share, we'll need to know that we've got enough of that data from people who are willing to share to be able to make those right decisions. So I think it will be more about open and honest communication between those technology providers and those data sources to say, you know, it's a bit like cookies. If you really want to find out what you're using cookies for, you've got to go into the next page and you've got to tick and untick everything. I think we've got to be much more transparent about this, so as actually people are willingly sharing it and they're seeing a real return on that investment. So they're loading up the app that, for example, the mobility as a service applications, and they're actually saying, I want to share this with you because I want to get more out of this system and I will benefit from it. So I think it's really about convincing those end users that it's for them, it's being done for them rather than for other purposes. So, but there is a mistrust about the sale of data to other sources. So I think we have to find a way of locking that down and preventing the sale of that data for other purposes.
Thanks, Scott. Just to say that you've got, you're still sharing your screen. And then I've got another question here about, you mentioned obviously that about shared vehicles. Oh, there you go, thanks. Shared vehicles and the shared economy. Do you think that's going to be affected, the uptake of that with the current COVID-19 situation?
Yeah, I mean, this has really thrown us, hasn't it? Because we're being told by government, go back to work and drive and don't use public transport, although that advice is changing rapidly. It's going to take a hit. The operators I'm talking to are saying, they're not expecting to, the modelling they're doing now is saying that actually they can only run at about 10% of their peak commuter capacity if we observe the 2-metre rule, which is devastating for them, because not only has their revenue dropped drastically, but then they need to run 10 times as many vehicles to move the same number of people, which is unaffordable. So it is a massive challenge, and the only way we're going to get through that is through a gradual transition back, and that is going to be linked to development of vaccination and people feeling more confident that actually we can manage these pandemics, we control these pandemics. The other thing that operators are doing, speaking to Great Western Railways and some of the bus operators, is that they're putting in systems to make sure the people that are using those vehicles are comfortable that they're being properly cleaned. Any swab on a bus from about 2 years ago, you wouldn't want to know what was on it. But now they're spending a lot more time and money on cleaning things, as you'd expect, to get that confidence back. So it's about consumer confidence. And one of the operators we're working for is expecting a return to about 80% of pre-COVID passenger numbers in 2 years. So they're expecting it to come back, but it's going to take some time.
Okay. I've got another question as well. When I was talking to some airline operators about a year ago, and they were talking about the move to electric airplanes, there was a concern about the amount of batteries that were available in order to be able to have that big, swift electric fleet. Do you, this thinking about moving to 80% electric in not that very far distant future, are there any concerns that we've got the batteries available to do that, and the actual raw minerals and things that are available?
There are concerns, but if you only go back about 3 or 4 years, so the development of battery technology has been exponential, really, because of this drive towards mainly electric vehicles, and those batteries are becoming more and more advanced and more efficient in terms of the way they are built and operate. And in terms of their life cycle, the materials are being reused for other sources, for other batteries, so they are being recycled. But you're right, the raw materials and the sources are they're not depleted. There's plenty there, but there's an environmental impact to creating and building them. Because of the uptake, they've got a long time to build all these batteries. So we're talking about only about less than 2% of cars on the UK's roads being electric at the moment, and that's slowly picking up to about 10% within 5 years with a strong wind. So actually, absolutely, we haven't got the resources and the technology there if we needed to do it now, but we've actually got 15 years to get there, and the technology is emerging so fast that you will see development in battery technology and battery type over the next 5 years that will give us that confidence that we can deliver the capacity.
Brilliant. Thank you very much, Scott. That's all the questions that I had. I was just going to ask John Harding one more question, because in Scott's talk he was talking about the future quite a bit. John, I was just wondering if you have any final thoughts on where you see that the future of AI and architecture from your perspective over the next sort of forthcoming decades.
Yeah, sorry, I'm just unmuting myself. Yeah, I think it's, well, I think the same problems that Scott kind of alluded to about sharing and trust. There's a bit of a connection there in a way between our presentations, in the sense that, yeah, I suppose the ethics of which we haven't really talked about, and is a hot topic obviously in AI for the last few years, but I think the ethics of data sharing, of training sets, and even in buildings, learning from post-occupancy. And at Reading, we have lots of projects going on, like measuring different room data and how buildings are used, and trying to get that data so it's open and shared. The danger is, of course, by the time it's ready to go to be used, the system you hope to use, because doing buildings and urban design, it takes years, right? It's not like software. by the time like you've made your project and it's like 5 years down the line, some of the things that you assumed have changed. So I think it's just keep, bearing that in mind. And I guess it goes back a bit to what Scott was talking about with the situation we're in now, because, we don't know what's going to happen. And it could be that in this time next year, we're relatively back to as we were. But we've made a lot of decisions on the short term that haven't benefited us long term. But it's also a great opportunity, certainly in buildings. Things like, working from home, how does that change the design of spaces, like, home offices and things. And there's all these different opportunities, I think, from what's happening now that we can build on, like cycling. Can we actually take that forward in our urban spaces and use this as a reason and a justification for doing things that long term will be good, regardless of the virus.
Thank you. Actually, were you just saying there about how working from home might change how we design offices? That leads us to a question which just comes through for Scott, actually. If everyone's starting to get used to working from home after the COVID pandemic, how will this drastically reduce the needs of public transportation?
Yeah, I mean, it's not really just public transportation, it's actually the travel as a whole. So we're very keen to, in a way, it sounds crass, but exploit this experiment we're in the middle of to say, look, most businesses out there were reticent to promote as much or anything like as much home working as we're seeing now. And most businesses that I'm interacting with, albeit we tend to be office-based businesses, so it's easier for us, are saying, hey, it sort of works. It's not perfect because we like human interaction, but it's making us think about our whole property portfolio, and do we really need to be having people travelling all the way to cities to sit together, or can we develop a scheme where we have maybe not everyone having to work from home, but have remote working hubs where you can walk there and you can do your interaction with your team. And as I say, the development of particularly the need for better broadband capacity and the systems. But, these tools we're playing around with now have been tested to death, and the developers of these tools, the software tools that allow us to hold events like this, they're loving it because this is actually giving them more feedback they'd have ever had in the next 5 years if it weren't for the pandemic. So what that means for us is we've seen a massive drop in travel because of this, and we want to promote the things that have come out of this that have been good for the environment and good for the climate. We want to capitalize on those and say, okay, if we can find a model that says we move back, at best we achieved, in the best places it was about 10% home working. If we can only go up to 20% home working, or even 30% home working, that would be like our transport networks being like school holidays all the time. So it's a massive, we only need small percentage changes and drops in movement to see a real release in capacity, and it makes you feel better. If you're traveling on a less congested network, it makes you feel better. So yeah, absolutely. We want to capitalize on the potential for home working to reduce those flows across all of the transport network.
Thank you. That's all the questions that I've got. John, Scott, have you got any sort of closing remarks that you'd like to make at all?
No, I was fascinated by John's graphics and algorithms, and I'm just, my head's spinning about how I might apply some of that to the transport networks now, because we've had a few trials, but the AI seems to work in one place once you've tested it to death and validated it, but when you try and do the same thing in another place, the characteristics are completely different, so it struggles. So that it'll be quite interesting to think about those challenges. About when you're dealing with buildings, you've got more of a static environment, whereas when you're building with a town and what people choose to do, it's much more challenging.
No, I just wanted to say, just thank Scott for his presentation, because I think it needs to be emphasized, like he was doing, about the social aspects of trying to drive change. And I mean, maybe my talk, I could give another talk, but this was a bit technical in a way because of the AI themes. But yeah, I think the reality of implementing some of these techniques is hard. And yeah, ways to kind of get people to share, I think, and you can only get that if people trust, you know, what you're doing, whether it's a human or a machine, right? So I think that's kind of the end lesson.
Absolutely, yeah.
Yeah. Thank you both. So I'm just going to, well, thank you both very much for those talks. I really enjoyed them. I thought that was, it was absolutely a fantastic event, and I'm thank you both very much for giving your time for us. I hope to see the rest of you. Thank you all very much for coming, and hopefully we'll see you all in our future events. Thank you.
Thank you.